The 12-volt relay, what's it used for? Well, it's really used for relaying. Let's take one apart, take a look at the inside, figure out what does what. Now this is the standard relay you can probably get from like Amazon. I think I spent maybe a couple bucks on this thing. This is the equivalent of a Bosch 5-pole relay. It's got a 30 and 40 amp capability depending on how it's being used. So let's talk about it for a second. There's 5 poles on the relay. All right, there's a switch path, which is basically this way, between 85 and 86. And then there's a connector path, which is this direction. And that happens either between 30 and 87A or between 30 and 87. Now let's open it up and see what's going on and how it works and everything else. Okay, here we go. Let's take a look here. So this is the inside of a relay. All right, so let's take a look at 86, pole 86. As we look at it, it's going through, and you can actually see it just sneaking through right there. That's going to be pole 86. 85, on the other hand, is also going through. It's actually connecting to the same isolator. You just can't see it. It's behind all this stuff that's going on. Now, when those two are energized, they energize this electromagnet. And the electromagnet clicks on. And when it's not energized, it clicks back off. Now, how does this work, or why is it there? Well, it basically that's controlling the pathway of power through the contact row here. So let's talk about the contacts. The contacts are a pass-through. Now 30 is common. It's always connected. But 87A or 87 may not be connected. So when the relay's in its off state, and this is the off state, 30 is directly connected to 87A at that point. When you energize the coil path, 85 and 86, that changes the pathway. So 30 is no longer connected to 87A. 30 is now connected to 87. So how's this used? Well, there's a lot of different ways we can use this, but I'm going to talk about a few of the more common ones. Let's start with polarity switching. Let's say that I've got a ground here that's constant, and I've got a positive signal that's being switched. But I need that positive signal to be a ground. Let's say I've got park kill coming in. Maybe on a Chevrolet Tahoe, we've got a park kill wire coming in here. And when you put the car in park, there's power here. And when you take the car out of park, there's no power there. And that's controlling the relay clicking on and off. Now, let's say that the siren you're using needs a ground input. It's not selectable for some reason. So if it needs a ground input, well, we'd be able to switch here with our positive wire. But what we can do is we can take that ground wire that's connected here and double it and connect it here as well to 87. All right, so when this thing's resting, there's no connection. Remember, 87 and 30 are not connected at rest. But the moment you throw the car into park, the relay energizes, and now there's a connection between 87 and 30. So you'd now have your ground path going through the relay to your siren. You throw the car in park, and basically the siren shuts up at that point. Now, another use for it would be like for a horn ring or something like that. We're gonna look at this differently. So the horn ring is going to basically work on these three terminals. So 30, 87A, and 87. We'll come back and talk about 86 and 85 here in a second and what they're doing. So in this case, we're going to have a signal coming from the horn, and that signal is going to 30. And then 87A is connected to the OEM horn. So this is outputting to the OEM horn. So when the relay is not doing anything, you honk your horn, it comes into 30, and then it outputs through 87A to the horn, and the horn does its thing. Now, the other terminal, 87, we're going to connect that to the horn ring input on the siren amplifier. And we now have the contact path set up. So the next thing we need to do is basically determine when the contact path changes from the OEM horn to the siren horn ring? Well, we're going to have a ground trigger here, and we're going to have a positive output, probably from a siren or something like that. Say like level 2 or something, you turn on your siren, it goes to slide position 2. It energizes this guy right here, and the relay is now connected between 30 and 87. So 87A is now just sitting there doing nothing. So remember, 87A is connected to the OEM horn. It's not seeing the signal at all. You honk the horn, it comes in through 30, it goes out from 87, and from 87 it goes to the siren amplifier, and you get your siren amplification, either the air horn or maybe it's cycling tones or something like that. Now another use for it would be we're basically amplifying the signal. So let's use this scenario. In this case, we've got a ground here on 86, and we have a switch coming in on 85, okay? Now that switch, let's say it's a little wire, it's only capable of maybe 3 amps, but we really need to turn on about 10 amps worth of lights. Well, what we do in this case is we hook the 86 to ground, hook 85 to our switch, and then we're going to provide a 10 amp power supply constant on 87, and 30 will be our output to all the lights, the 10 amp load. And when we turn this on, it connects 87 to 30, and now we have a 10 amp pass-through circuit. And remember, they're isolated, so the switch is actually isolated from the output. So you're not going to burn the switch up, you're not going to burn the wire up, you're not going to burn the car to the ground. Now another use, probably a little bit less common these days, but still sometimes it may be necessary, would be if we have 2 of these. All right, and if we have 2, we can do what's called a 5-wire connection, where we're basically changing the polarity of the output. So let's use a window motor, for example. Window motors rely on one wire is positive and the other wire is negative, okay? And that's basically forcing the window motor to go up, and then you flip-flop them. So wire 1 that was positive becomes negative, and wire 2 that was negative becomes positive, and that causes the window to go down. Well, you can do the same thing here. You can basically take and use the pass-through circuits. Remember, 87A is the pass-through. So the wire coming from the window switch is going to go to 87A on 1, and it's going to output to the window motor. And then the other wire is going to go to 87A here, and it's going to output to the window motor. And what you're going to do is you're going to find the polarity you need for the window to go down. So if I need the window to go down, maybe I'll have a ground here and a positive here. And this is just pass-through, okay? And when I energize the relays, this forces ground out this lug, and it forces power out that one, and that causes the window to go down. All right? That's pretty much it. That's probably the most common use in the upfitter industry. You know, you might find other ways to be creative, and you may sometimes have relay after relay after relay. But if you want to look up some schematics or something like that, just go to Google, type in 12-volt Bosch relay wiring schematic examples. That's probably going to pull up a couple million hits, and that should get you close to where you need to be. Well, that's all I've got for now. Till next time.